Hey guys, this is Mrs. Cutting. I am wearing my headphones today because this morning the heater in my classroom is making this obnoxious squealing noise. So I'm hoping that with me wearing the headphones, you won't have to hear that throughout the video. Anyways, this is a recap of this distributive property thingy that we've been working with the past few days. You are either going to write this on a lined sheet of paper, or if you have space on one of the blank pages in the back of your workbook, you can write it there. You could even write it back cover, front cover, something like that, okay? But you need space to be able to take some notes. All right, so this is distributive property video. And what I write, you should also be writing. Okay, so yesterday's opener kind of went over the parts of the distributive property that we've worked with. So yesterday's opener, we started with our area models with whole numbers. So we're going to put that in there first. Area models of whole numbers. And of course, we like to make all of our titles just a little bit fancy. Okay, we're going to dive right in with an example. I'm going to do 5 times 87. So to draw my area model, we know we're not at all drawing this to scale because it would have to be extremely short and very, very long, and we're not doing that. Okay, but I'm starting with a rectangle. I'm doing 5 times 87, and my 87 I'm going to cut up into 80 plus 7. So 80 and 7. So then I'm going to multiply my pieces. So 5 times 80 is really 5 times 8 is 40. And then 10 times bigger makes it 80, so 10 times bigger makes it 400. And then this piece is going to be 5 times 7, which is 35. Okay, so then we're going to write out what we did, which is 5 times 87. This is our distributive property sentence, the long thing we've been writing out. In our area model, we cut that into 5 times 80 plus 7. And this time I'm going to draw these arrows because the distributive property tells me that instead of adding 80 plus 7 and then multiplying it by 5, I can pass out my 5 with my times sign and do 5 times 80 plus 5 times 7, which is exactly what I did when I broke up my area model. 5 times 80 plus 5 times 7. 5 times 80 gave me 400, plus 5 times 7 gave me 35, which is 435. So distributive property says I can break this out of the parentheses jail if I distribute, if I pass out that 5 and that times sign to both numbers and then add them together. So instead of having to do 5 times 87, I can do 5 times 80, 5 times 7 and add them together, which is huge because I can't do 5 times 87 in my head without writing something down. But I can do 5 times 80 and I can do 5 times 7. Okay, so then our next part is area models with variables. This we looked at with our lesson 10 video and then a little bit in class yesterday. So this is area models with variables. Oh, if you're listening at this point, will you just draw a couple of hearts next to your area model up there? Thank you. Okay, so this is area models with variables. we gotta make our title a little bit fancy. Okay. So I'm again gonna start with my area model. So I need a rectangle, and I am gonna break it up. My length here is 8. My width is gonna be X. This piece is gonna be X. This piece is gonna be 4. So this whole length is not 4x. It is actually x plus 4. So I'm going to fill in my area model. 8 times x, we write that as 8x. 8 times 4 is 32. Okay. So then we're going to write our area 2 different ways. First, actually, we're going to write what our length and our width is. So our length, that side length is 8. Our width is x plus 4. So then for our area, we're going to first write it as the product, which means the answer to a multiplication problem, of length times width. So when I write it as the product of length times width, that's going to be 8 times x plus 4. 8 times x plus 4. And then I'm going to write it as the sum, so adding, of the smaller rectangles. This piece was 8x, this piece was 32, so writing it as an addition problem is 8x plus 32. Okay, what we just did was using the distributive property. Check this out. So we started with this as our length times our width, 8 times x plus 4. X plus 4 was stuck in parentheses jail. We can't do anything with it. The distributive property comes along and says, hey, we can distribute, or we can pass out this 8 with the times sign to both of these things, and then we can break it out of parentheses. So instead of having to add x plus 4 first and then multiply it by 8, we can do 8 times x plus 8 times 4. And we know 8 times x is 8x, and 8 times 4 is 32. Hey, guess what? That is the same thing that I got up there. So I can go from the product of length times width to the sum of those smaller rectangles by using the distributive property, by breaking it out of that parentheses jail. If you are listening at this point, somewhere over here, will you just draw a couple of little squiggly lines? Doesn't need to be anything fancy. All right, I need to go on to my next page. And this is a long title. I don't know if we're going to be able to make this one fancy. Using distributive property. To write equivalent expressions. I know, that one's definitely a mouthful. Using distributive property to write equivalent expressions. I said I didn't know if I was going to be able to make it fancy, and I jinxed myself because look, I have a scribble. Ugh. All right, well, we can still decorate it. Okay. So with our area models, we've been looking at area as a product. In parentheses, we're going to say multiplication. And area as a sum. In parentheses, we're going to say addition. Look, I can draw straight lines and then I can't at all. Okay. So I have x times parentheses 4 plus 5. That's my area as a product. So I'm going to draw these arrows because the distributive property says I can break it out of parentheses jail if I take that x and that times sign and multiply it by the 4 and by the 5. So my in-between step is I'm going to write this with my times signs, x times 4 plus x times 5, x times 4 plus x times 5, okay? And then I'm going to rewrite it, kind of our more formal algebraic way of writing it. X times 4, we just write that as 4x, plus x times 5, we write that as 5x. So I am distributing, I'm passing out this with the times sign, I'm writing it with the times sign, and then I'm kind of writing it a little more formally, a little more algebraically, or as one of my classes decided, it sounded kind of like algebraically, so a little bit more algebraically. All right, 6 times y plus 2. Distributive property says I can pass out this 6 with the times sign, break it free of the parentheses jail if I multiply it by both of these things inside the parentheses. So I'm going to write it with my times sign first. 6 times y plus 6 times 2. And then I'm going to write it a little more algebraically, kind of simplify it. We're familiar with that word from fractions, but really I'm going to write it a little less complex, a little simpler, a little shorter if I can. So 6 times y is 6y plus 6 times 2 is 12. Okay, one more I'm going to do completely, and then I'm going to have a couple that you're going to try. I have y times x plus 5z. Distributive property says I can distribute, I can pass out that y with the times sign. So I'm first going to do that, even though it's going to be really weird to write this way. Y times x plus y times 5z. I'm actually going to put the dot in here because all three of these things are being multiplied together. And we know with multiplication, we can switch that order around. Okay, so then I'm going to formalize it a little bit. When I have multiple variables being multiplied, yeah, we put them in alphabetical order. So y times x, x comes first in the alphabet, so this becomes xy. Here I have two variables and a coefficient, a number that I'm multiplying by the variable. Coefficient, that number goes out in front, and then the variables in alphabetical order. So this is going to become 5yz. I know, totally weird. This is just the algebraic notation things, couple of little things, yeah. Okay, so I'm going to give you 3 that I'm going to have you pause and try, and then you'll come back on my video and check them with me. So I have z times 7 plus 9. I have 8 times x plus y, and 4 times 2y plus x. So I'm going to have you pause, use these examples to help you. You're going to write it first with the times sign and then without the times sign as our more algebraically way of doing it. So pause to try those 3 and then come back. Pause. And welcome back. I'm switching colors. I'm not exactly sure why. Okay, so distributive property says I can break this out of its parentheses jail. This is z times 7 plus z times 9, which is 7z plus 9z. This one, I'm passing out the 8 with the times sign. That gives me 8 times x plus 8 times y, which is 8x plus 8y. And this one, I'm passing out the 4 with the times sign. That gives me, arrow. 4 times 2y plus 4 times x. 4 times 2y, that's 4 times 2 times y. I can do the 4 times 2. That makes 8 times y, so 8y plus 4x. All right, I'm going to give you 3 more, last 3. These 3 you are going to do on your own. I am not going to go over them in the video. This is 3 times x plus 2, y times 3x plus 5, and z times 4 plus 8. So when I check your remote learning, you're going to have these last 3 done as well. Okay. I think that's it for today's video. Let's see how I'm doing on time. 17 minutes, not bad. All right, I will see you next time.